So yeah, hello everyone. Very good evening to all of you. I hope I'm audible and visible. So let's wait for 5 to 10 minutes so that everyone can able to join this session. So, hello everyone, a very good evening to all of you. I hope I'm audible and visible. Okay, so let's start the session. My name is Pooja Verma and I am a research scholar from IIT Kharagpur and instructor for this course is Professor Shantanu Chattopadhyay, Electrical and Electronics Engineering Department, IIT Kharagpur. This is a week 10 live and interactive session on digital circuits. You can use chat box for asking and interacting. Otherwise, you can unmute yourself and ask questions. So I hope all of you have gone through this week video lectures. So for this week, these are the some contents which have been covered for this week video lectures. So, so first one is VHDL and introduction, then VHDL entities, architecture, and then about microprocessor, memory, and lastly discussed, I think introduced 8085 microprocessor only. So move to the questions. Good evening everyone, good evening. So yeah, first question is which of the following statement which of the following statement my voice is not clear now. Hello, uh, others can confirm it. Okay, so first question is which of the following statement is false regarding the VHDL entity declaration code shown below. So that code is given as a entity logic block is stored X in steady logic or Y is also in steady logic, Z is in steady logic, and F is given as a out steady logic. Okay, so the options are given as like A logic block is a user defined name of the digital circuit. So yeah, this logic block is user defined already. We know that. Okay, so this one is correct. Now they have asked option B is X, Y and Z are one input port names. So yes, these are the inputs because here it is written in, right? So these are the here written as a in. So this is a in studied logic. And third one is given as a F is a multiple bit output port name, right? So F is a single, but here F is given as a single bit signal, not a multiple bit signal. Okay, it is clearly visible. And option D is none of the above. So option C is a false regarding the VHDL entity declaration code. Okay, so F is represented as a output port with the type STD logic, which represents a single bit signal, not a multiple bit signal. Okay, this F. So F is the correct answer. So F is the false statement and C is the correct answer for this question. Okay. Okay. So moving to the next question. Next question is identify the basic logic block described by the following VHDL code. Circuit example in a processes in the processes there three variables are given A, B and S, and the code is begin if S is equal to 1, then Z is will be selected as Z, the output will be A, otherwise the output will be B. Then it end if and in process. So which option is correct in this? So option is three input OR gate. No, here Z represented as a output because here it is given if S is equal to 1, then output is A, otherwise B, right? So that means A and B are the inputs. A and B are the inputs and Z is output. Just this Z is output. So yeah, and S is you can say it's the selection line. Right? So here two inputs, one output, one selection line, right? So what are the possibility? So most of the possibility it is a mux, right? Because in half adder it can be possible, but it will not be because here it is given if S is equal to 1, then output is A. That means that can have 2 into 1 multiplexer. That means A and B, two are the inputs, one selection line. If it is 3 to 1 mux, so that is not possible. 3 to 1 mux and one output. So if S is equal to 1, then it select the output will be equal to A, and otherwise if S is equal to 0, then output will be B, right? So it is a 2 to 1 multiplexer. Okay, we can identify like this. A, B and S, two inputs, and the one is the selection line, and Z, one is the output. Okay, so option B is the correct answer. It is a 2 to 1 mux. Okay, so moving to the next question. So next question is theoretical use. Which of the following keywords define a one-dimensional array with elements of the bit data type? Option A is bit, option B is bool, option C is bit vector, and option D is the integer. So here they have asked which of the following keywords define one-dimensional array with element of a bit data type. So already we know that bit represent a single bit that can take 0 or 1, right? So it is a not array, it is a single bit representation. So this option A is not a correct answer to define an array. And next one is bool. So in the bool we can also know that the output is taken or input is given either true or false statement only, right? So this type mean of logic that involves truth condition, but it is not used to define a bit array. Okay. Now next one is a bit vector. So bit vector is a one-dimensional array of a bit element. This array can store multiple bits, each of which can be either 0 or 1. Okay. It is used for representing group of bits. And while integer is a keyword to use to define a variable that can hold a whole number, positive or negative. It is not related to any data type or array of bits. Okay, so option C is the correct answer, and description I have also given here, and it is also uploaded to the drive from where you can access. Okay, so that's why I have given all the what is a bit bool or bit vector and integer. Okay, so option C is the correct answer for this question, that is a bit vector. Bit vector can be used to define a one-dimensional array with elements of the bit data type. It can be store multiple bits of 0 or 1. Okay. So moving to the next question. Next question is also a theoretical question. So which of the following statements is false regarding signals and variables in a VHDL? So option A is a signals must be declared inside a process. Okay, option B is signals follow the notation of event scheduling. Option C, variables get updated instantly without any delay. And option D is none of the above. They have asked which of the following statement is false regarding the signals and variables. So signals must be declared inside a process. So it is not a compulsory signals must be declared inside the process. Signals can be declared outside the process in, in the architecture or entity declaration, allowing them to used across a multiple processes throughout the entire design. So variables, on the other hand, can be declared inside the process, but signals can be defined the or declared the outside the process. It is not declared the inside the process in order to access all the entities or entire design. So this one is a false statement. If this one is a false statement, that's why option A is the correct answer for this question. Now next I can describe the other options also. Signal follow the notation of event scheduling. So in the VHDL, updated based on a event scheduling. That means changes to the signal value occurs at the end of the simulation cycle when events are processed. So if signal is assigned a new value, a new value, that assignment does not take effect until the next simulation cycle. Okay, so when that cycle will complete it, then the signal follow the next instruction. Okay, now next option is variables get updated instantly without any delay. So in the VHDL, the variables are updated immediately when assigned a new value That means that reflect the new value in the next line of the code within the process. And there is a no delay for updating variable value. Okay. So in that case, option A is the correct answer for this question. Signal must be declared inside the process. This one is a false statement. That's why it is a correct answer for this question. Okay. Moving to the next question. So now next question is, which keyword in VSDL is used to describe how input and output ports of a component instance are connected while instantly the component. So option A is port list, option B is variable, option C is process, or option D is port map. So they have asked the keywords in a VSDL used to describe how input output ports of a component instances are connected while instantiating the component. So let's see the option by option. Okay, what they means and what are the functionality. So first option A is port list. So there is a no keyword called port list in the VSDL for connecting ports. So the term port list may refer to the list of the ports defined in a component but does not describe the connecting mechanism during instantiation. Okay, now next one is a variable. The variable keyword in VSDL is used to declare variables that can hold a temporary data within a process. It is not related to input-output ports of the component. Now next one is a process. Process is also not related to connecting the input-output ports of a component. It is a keyword which used to define a process block where concurrent statements can be executed, and it is not related to the input output ports of a component. Now next one is a deep port map. A port map is a keyword specifically used to associate the ports of the component with signals in the surrounding architecture. It provides a mapping of the input and output ports of the appropriate signals. Okay, so port map is the keyword that used to connect the ports or instances of the signal in the surrounding architecture. Okay, so it can be used as a input output ports of a component instances are that connected. So that option D is the correct answer. That can be used. Okay, but others are not used. Already, as we have seen that what is the meaning of these keywords. Okay, so option D is the correct answer for this question. Okay, so now moving to the next question. So next question is also, which block within a microprocessor performs the integer, arithmetic, and bitwise logical operations? So option A is arithmetic logic unit, option B is register file, option C is control unit, and option D is memory block. So any one of you can answer this question. This means I hope all of you have studied about the microprocessor. So which block within a microprocessor perform an integer, arithmetic, and bitwise logical operation? So we will go through the options. That is what is the working, what the options are, what is the working of the arithmetic logic unit, register files, control units, and memory block. What actually they do? I have written here. So basically, arithmetic logic unit is a is a component in a microprocessor that performs arithmetic and logical operations. Okay, arithmetic operations, addition, subtraction, multiplication, and division, as well as the logical operations. It directly handles integer calculation and bitwise logical operation. So ALU, or you can say that arithmetic logic unit within a microprocessor, performs the integer arithmetic and bitwise logical operation, while the register files consist of a set of registers used to hold the temporary data for processing. Okay, and control units, also the control unit used, or control units only directly movement of the data between ALU register and memory. It manages the executions of instructions but does not perform the arithmetic and logic operations, while memory blocks are responsible to store data and instruction but not execute the arithmetic and logical operation. So memory blocks are used for storing the data. Control units are managing the execution of the instructions, while register files are used for store the or hold the temporary data while the processing, and arithmetic logic unit are used to perform the arithmetic and logical operations. Okay, so option A is the correct answer for this question. Yeah, correct in 5. Thank you for your answer. So yeah, now moving to the next question. Now next question is also, what are the three fundamental steps for executing an instruction in a microprocessor? So what are the three fundamental steps for executing the instruction in a microprocessor? So any one of you can answer this question. So option A is fetch, read and store. Option B is read, interpret, decode. Or option C is fetch, decode, execute. Or option D is store, decode and execute. Yeah, option C is the correct answer. So three fundamental steps for executing an instruction in a microprocessor is the fetch, decode and execute, and all other options are not in the correct sequence. Okay, first we will do the we in the instruction we first fetch the instruction, then decode it, then execute it. This is the correct sequence. It is, these are the not the correct. First fetch is correct, then read is not directly we cannot read. We must decode the instruction, then we can execute. Okay, so option C is the correct answer, and in detail too I have written here. You can read it. Okay, so now next question is, what is the maximum memory that can be accessed in 8085? So anyone of you want the answer in the, yeah, the correct file? But how we can know that what is the maximum memory that can be accessed by 8085? Okay, so as we know that the address bus in 8085 processor is 16, right? 16 bits already, we know that. Okay, so what will be the number of addresses that we can store?
2 power 2.
Yeah, 2 to the power 16. Right. Then that is what will be the value of 2 to the power 16? That is, anyone of you can calculate and answer this question. Yeah, correct file, that is 65,536. 65,536 bits, right? Bits not, it is that much of memory location we can have memory location, and each memory location can hold 1 byte of data, right? Each memory location can hold 1 byte of data. So, 536 bytes. That will be equal to 64 kilobyte we can write. Okay. So that's why 64 kilobyte option B is the correct answer for this question. That is the maximum memory of that can be accessed in 8085, that is 64 KB. Okay. So now yes, moving to the next question. So this one is also general question or basic. 8085 is a 8-bit general purpose microprocessor. Option B is 16-bit general purpose microprocessor. Option C is 32-bit general purpose microprocessor, or option D is 64-bit general purpose microprocessor. So yeah, 8085 is a 8-bit general purpose microprocessor that is capable of executing the wide range of instructions and interfacing with memory and input-output devices for various computing tasks. So it is a 8-bit general purpose microprocessor. So moving to the next question. So next question is also VHDL and Verilog are: option A is software description language, option B is assembly language, option C is hardware description language, or option D is none of the above. So yeah, the VHDL and Verilogs are the hardware description language. Okay, that can be used in a digital digital circuit. So okay, I will describe here the options by option. So what is a software description language? So as already we know that a software description language is typically used for software development, does not accurately define the purpose of VHDL Verilog. So these languages are not designed for writing software programs, but rather for describing hardware behavior and structure. Okay, so now next one is the assembly language. The assembly language is a low-level programming language used for writing programs that interact closely with the hardware and at the machine. So VHDL and Verilog are not assembly language. Now next one is hardware description language. Hardware description language, that is a VHDL and Verilog. Both are classified as a hardware description language. They are used to model, simulate, and synthesize electronic systems such as a digital circuits and FPGA. So hardware description languages allows designers to describe the behavior structure of the hardware components in a high level or abstract way. Okay, so VHDL and Verilogs are the hardware description language. Option C is the correct answer for this question. So now moving to the next question. The next question is 8085 microprocessor has how many pins? So already you know that it has a 40 pin microprocessor. 8085 is a 40 pin microprocessor. So the 40 pins are divided in address bus pins, that is A0 to A15, total 16 address bus pin, or you can say that address lines. Now next one, data bus line, that is D0 to D7 for data transfer. So total 8 pins for data lines, and control and status pins are total 16 in order to control the signal and check their status, and 2 are power and ground pins. And ground pins. So 8085 microprocessor has total 40 pins. Now moving to the next question. Next question is also theoretical. Which of the following converts the assembly language into a machine instruction? Option A is assembler, option B is compiler, option C is interpreter, option D is processor. So already all of you I think know that. So you can at least answer in the chat box. Try to interact and give the answer. Which of the following converts the assembly language into a machine instruction? So in order to convert the assembly language into machine instruction, the assembler is used. Yeah, assembler is a tool that translates assembly language into a machine language. Here the processor can directly execute the instructions. Okay. Now next, what is the purpose of compiler, interpreter, and processor? So compiler transfers the high-level programming language, that is C, C++, or Java, into a machine language. Okay, it does not convert the assembly language to a machine language. Now next, interpreter and interpreters translate the high-level programming language into a machine language that executes instruction directly. Okay, but it is used for Python, JavaScript, not for assembly language. And while the processors can execute the machine language instruction, it does not convert assembly language to a machine language. Okay, so assembler is used to convert the assembly language into a machine instructions. Okay, so moving to the next question. So next question is also a theoretical question. So in an Intel 8085A, which is the first machine cycle of an instruction? Option A is an opcode fetch cycle, option B is a memory read cycle, option C is a memory write cycle, and option D is an input output read cycle. Yes, why? This is a memory fetch cycle and opcode fetch cycle. So the time required by the microprocessor to complete an operation of accessing memory or input output devices is called a machine cycle. Okay, so the 4 steps are involved for machine cycle. That is, first one is a fetch, then decode, then execute or store. Okay, so in execution of any instruction, first cycle of opcode fetch. That is fetch. It is called the opcode fetch cycle. After that, depending on the given instruction, the memory read or write operation, or also IO read or write cycles will occur. Okay, So in Intel 8085A, which is the first machine cycle of an instruction, that is a opcode hex cycle. After that, decode, execute, and store. Okay, depending on the instruction given to the microprocessor. So option A is the correct answer for this question. Okay, so moving to the next question. The clock speed of the 8085 microprocessor is option A is 1 megahertz, option B is 1 kilohertz, option C is 3 kilohertz, or option D is 3 megahertz. Yes, Payal, correct one. The 3 megahertz is the clock speed of the 8085 microprocessor. Okay, so option D is the correct answer. Clock speed of the 8085 microprocessor is 3 megahertz. It is given. Okay, so now moving to the next question. So next question is, which of the following is true? Option A is a VHDL is a sequential language. Option B is VHDL a concurrent language. Option C, synthesis converts higher level description to a lower level description. Or option D, both B and C. Okay, so which of the following is true? The VHDL is a sequential language. So the behavior of a VHDL can be a sequential. It is not a sequential language. It is fundamentally designed to describe concurrent hardware behavior, not a sequential. So multiple processes can be executed simultaneously, but it is not a sequential language. So VHDL is a concurrent language. So VHDL is a primary concurrent hardware description language that allows for the description for multiple operations happening at the same time. Okay, and now next one, synthesis converts higher level description to a lower level description. Okay, so synthesis is the process for converting high level description into a lower level description that can be implemented on a hardware. So that's why option B and C both are correct. So option B have an option that both B and C. So option D is the correct answer for this question. Which of the following is true? That is, VHDL is a concurrent language and that synthesis converts higher level description to a lower level description. Okay. Synthesis is used for this process for converting high level description language into a lower level representation. Okay, so moving to the next question. Now, next question. Which of the following operation represents the structural model for NOT gate? So anyone of you can see and answer this question. Which of the following options represent the structural model for NOT gate? Please answer in the chat box. So since what will be the structural modeling? So structural modeling defines only the components with their input and output ports, but the name of the component can't be same in reserved word for a VHDL. Okay. So yeah, Dina. Here I have that's why I have given some explanation. So structural modeling defines only the component with their input and output ports, but the name of the components can't be the same of any reserved word of the VHDL. So here not is a reserved word, so it cannot be defined in a modeling in the component or input output ports name. So that's why option third one is not a correct one, because here not is a reserved word in the PHDL. Okay, and option one is also not, because here they have started, but what is a X study in study logic and out study logic, but they have not defined what is a not yet what is a component. And option B, option B is also one function is missing, so it is also not correct. So option fourth one is correct. So because it does not consider any reserved word in the component list, so the architecture start not gate of my function begin the component not one, that's why here it is. But here they have used the function name, that is not, it is a operation already, I know that. So we can't use in the component list. So port X in study logic, Y is a one is input, Y is output, and the component they have ended and not gate. So option 4 is the correct answer if you see that. Okay. Option 3 we cannot consider because the not that they have defined, it is a reserved word. Okay. In the VHDL code, because it is a directly a function. We cannot use not or and. These are, we cannot use not or and all these components. Okay. So moving to the next question. So yeah, next question is what logic circuit is described by the following code? So architecture gate of my gates, the function name is begin with AB select Y is equal to 0 when it is a 0, 1 or 1, 0 and 1 when other. AND gate. Which gate it can be? It is a option A is NAND gate, option B is NOR gate, option C is XNOR gate, or option D is XNOR gate. Yeah, it is a XNOR gate because we can see the option by option. For NAND gate already we know that AB, that's Y is the output. Yeah, 0 0 0 1 1 0 1 1. So what will be the output for NAND gate? It is a 1 1 1, it is a 0, right? But here it is given 0 when 0 1 and 1 0 and when 1 when it is a others, but that option is not correct. Similarly, we can see for NOR gate also, right? So what will be the output for NOR gate? Opposite of OR gate, right? 0 0 0 1. That is also not correct because they have asked when 0 0 0 1 1 0 1. So when 0 1 and 1 0, it will be the output will be the 0. When inputs are same, then it will be 1. Okay. So in the XOR gate also it is not possible because in the XOR gate when the inputs are same, the output is 0. When it is different, then it is 1. Okay, and XOR gate is opposite to XOR gate. So XNOR. Option D is the correct answer for this question. It is 0 when the inputs are different. When inputs are same, then the output will be 1. Okay. So the logic circuit is described by the following code is a XNOR gate that reflects the XNOR gate property. Okay. So moving to the next question. So next question is, which of the following logic described by XOR gate? So what is the expression for the XOR gate? Anyone can answer in the chat box. Please try to answer. What is the logic expression for XOR gate? D bar B, B bar A. Correct, fire. Right. So which option is correct? Which logic describes the XOR gate? That is A dash B plus B dash A. Right. So let's see option by option. Let's see the just clearly options clearly so that you can answer. So what this represents, y is equal to not a, that means a dash, or here it is given or means plus, right? Not b, that means b dash, then they have written and, so that means and, not a or not b. So again a dash plus b dash, it is a representation of first option, right? So it is representing, if we again synthesize it, so a dash into a dash plus a dash b dash, again a dash b dash, then b dash b dash. Just a minute, we will go option by option so that everyone can able to understand. Okay, so a dash will a dash only, and a dash b dash, these are the same. We can write it once plus b dash, right? If we take a dash common, so 1 plus b dash, then plus b dash, what will be the answer? A dash plus b dash. It is not a logic operation expression for XOR gate. Already we see that what will be the a dash b plus b dash a. It is the logic expression for XOR gate. So option A is not a correct answer. Now next we can see for option B. Here it is written not a, means that is a dash plus b, then they have ended a plus b dash. We further synthesize that a dash a plus a dash b dash plus ab plus b to b dash. So that will be the 0. Already we know that. This one also. So it is a dash b dash plus ab. But this is not a XOR gate. It is a XNOR gate. So option B is also not correct. Now go the option C. So option C is A dash, that is a not A and not B. Then or not A and not B, right? So it will be the A dash B dash because both are same. So if we add this, we will get A dash B dash only. So option C is not, option C is also not correct. Now we can see to the option D. So option D is not A that means A dash and B plus A not B. So it is a logic expression for XOR gate already. We know that. So that's why option D is the correct answer for this question. Okay, not C. Now I think all of you have clear. Yeah, option D is the correct answer. Now next question is, look the code given below, which of the following option is implemented by the VSDL code. So the function will say my function of my logic is y is equal to A and B XNOR C in my function. So which option is correct for this question? So if you can answer this question. Yeah, D is the correct answer, but how? After expanding or solving this question, right? So A, B, XNOR C, that means B dash C dash plus BC. So we again multiply that A B dash C dash plus A B C, right? So check in the answers which option is matching. That is option D, ABC. We can if we rewrite it, that is ABC plus A B dash C dash. Okay. So option D is the correct answer for this question. So now moving to the next question. So now next question is, what is the VHDL code for the logical function AB-C plus ABC plus BC? Please check in the options and try to answer this question. What is the VHDL code for the logical function? Logical function is given as A B-C plus ABC plus BC. Regarding this logical function, which VHDL code is suitable? So option 1, go by options. Option 1 is, first one is a architectural logic of my logic is, again the output here, if we can solve this, that is A and B and C, then again and B and C. So what will be the function we will get? That is A B C into B C. That means we multiply, we will get only A, B, C. So it is not matching this logical function, right? So ABC, please try to answer in the chat box which options can be correct. Okay, so first one is not matching with this logical function because that is implementing only ABC, right? Okay, so how would you get to know what function it is implementing? So as the process in the VHDL, the function is implemented after optimization. So first we need to optimize this function. Okay, so it is given as a first, let's see what function it is given after optimization. Okay, so A and C is the common in these two. So if we take common, then P dash plus B, right, plus BC. Now it is 1, already we know that. We will get AC plus BC. Now check which function, if any logical expression or function is given, so first check by optimization, then try to implement it. First optimize the function, then try to write the VHDL code corresponding. So now, but first option we are getting only ABC. It is not, option 1 is not correct one. I will see that answer. Okay, we will check. Okay, so now next one is option 2. It is implementing y is equal to a and c plus b and c. Yes, it is implementing a and c or b and c. Yeah, option 2 is the correct answer. Now we can check the other options also. Option C is implementing A and C, but here it is a and, B or C, or means plus. Already we know that and means multiplication. So if we again multiply, we will get ABC plus AC only. So this one, option C, is the correct one. Now we can check for option D or fourth one also. So it is A and B and C plus B, C. So option 4 is also not correct. So option 2 is the correct answer. Okay, for this question. Okay, so moving to the next question. So now, next one is, which of the following is not representing a nibble? But how? We can describe option 3 is not representing the nibble. Yeah, a nibble is a group of 4 bits. Already we know that. A nibble is a group of 4 bits. Is a group of 4 bits. So let's go option by option. So option A is X, that is equal to 0, 1, 0, 1. It is a 4 bit, it is a group of 4 bit, group of 4 bit, 4 bit. That means it is representing a nibble. So it is a correct one. Now check for option B. So option B is steady logic vector 0 to 4. That is vector 0 to 4. That means 0, 1, 2, 3, 4, right? So if we see, it is a total 5 bits, but nibble is representing as a group of 4 bits. So option B is not a nibble. So option B is the correct answer, because they are asking which of the following is not representing a nibble. Now option C, you can check it. That is also a steady logic. Vector 3 down to 0. That means 3, 2, 1, 0. It is also group of 4 bits. So it is also representing the nibble. Now if we see, check for the option B, that is a bit vector 1, 2, 4. That means 1, 2, 3, 4. It is also a group of 4 bits. So it is also representing a nibble. So only option B is not representing a nibble. So option B is the correct answer. Because in the question they have asked which of the following is not representing a nibble. Okay. Okay. Yeah, Payal, your explanation is correct. Thank you. Okay, so moving to the next question. So identify the correct VHDL statement for a clock with frequency of 50 megahertz. Let the signal be a clock. So which option is correct? Option A is a clock is equal to not clock after 10 nanosecond. Option B is not clock after 20 nanosecond. And option C is not clock, or option D is not clock after 1 nanosecond. So they have asked me the question, identify the correct VHDL statement for a clock with frequency F is 50 megahertz. So which one is correct? So anyone of you want to try this question? The F clock is given as a 50 megahertz. So how we can solve this question? How would we know to not clock after 10 seconds or 20 nanosecond, or either clock or not clock? So F clock is given as a 50 megahertz. Yes, 1 by 50, but what will be the value, or we can explain this? Okay, so here they have asked in the nanosecond, that means we need to find out the T clock. That means 1 by F clock, the time period of the signal. So that is 1 by 50 megahertz. Already we know that that is 10 to the power 6. Megahertz is written, it is, that means 10 to the power 6 hertz. Okay, so 1 by 5, you can realize it 10 to the power minus 7. If you further solve it, you will get 0.2 into 10 to the power minus 7 to further second. Okay, now if you gain, so you will get 20 nanosecond. Okay, so the T clock we will get the 20 nanosecond. So they have asked, identify the correct VHDL statement for a clock with a frequency of 50 megahertz, that the signal be a clock. So that means that we can say that the signal is clock. So clock after 10 nanosecond or 20 nanosecond, or not clock. That one is not correct answer. Not clock after 20 nanosecond. So for any signal, if overall clock period is given, that means it is given for low as well as for high also, right? For one period it is given 20 nanosecond, right? That means it is allotted 10 nanosecond for high level and 10 nanosecond for low level, right? That means T clock is equal to T high plus T low, right? So T clock, we know that it is a 20 nanosecond. That means 10 for high and 10 for low. T high is 10 nanosecond and T low for is 10 nanosecond. Okay, so that will toggle the clock every 10 nanoseconds, which means clock period of 20 nanosecond. That means in the question is not clock after 10 nanoseconds because we need only either high level or low level. Okay, so in that case option A is correct, not option B. Not clock. The 20 nanosecond represent the whole period. Okay, so we have to take the lower one. That means not clock after 20 nanosecond is not a correct answer. Correct answer is not clock after 10 nanosecond. I think you have understand this one. So this 20 nanosecond represents the whole period, not high or low. So if we want to write or read something in the VHDL code, we have to clock up either at high level or either low level. Okay. So we have to go to not clock after 10 nanoseconds. Okay. I think I hope all of you understand this question. Yeah, it can be a label triggered or edge triggered. It is not mean that. It is not related to either level triggered or edge triggered. It is related to simple statement in VHDL code. Whenever we are writing any code in the digital circuits, already we know that any gate is represented by a clock cycle, right? So at which time it is active or not active. It is related to that clock signals. Just simple understanding, it is a represented the whole period T, right? Already we know that T is a whole one period. So it is representing the wholes. It is for low as well as high. If you divide it, is a 10 nanosecond for high, 10 nanosecond for low. Okay. So moving to the next question. So next question is write the VHDL statement for the below logic circuit assuming that each stage has a propagation delay of 10 nanoseconds. So what will be the VHDL code for this? So what will be the output for this logic? That is A and B or C, right? And here it is given that assuming each gate has a propagation delay of 10 nanosecond, 10 nanosecond for this gate as well as 10 nanosecond for this gate. So we have to write a correct VHDL statement for the given logic circuit. So which option can be a correct? That is option A is C equal to A and B after 5 nanosecond. Y is C or D after 5 nanosecond. Yeah, file D can be correct, but here it is given both propagation delay we have to include. So option B is A and B after 10 nanosecond, Y is C and D after 10 nanosecond. So option Y is C or A and B, where it is given, and option D is Y is equal to C or A and B after 10 nanosecond. So option D can't be correct because we have to take 10 nanosecond for this gate delay and say 10 nanosecond for this gate delay. So we can assume that the output of AND gate is D. Okay, that's why they have here given in option C and B as well the option B. So D is equal to A and B will, here it is given assuming that each gate has a propagation delay 10 nanosecond. A and B will operate after 10 nanosecond, that means nanosecond, and Y is equal to D or C. We can see that C, D after 10 nanosecond. So option B is the correct answer for this question. Option D can be, but they have merged also C or A and B after 10 nanosecond, not whole process after 10 nanosecond. It is for AND gate also taking 10 nanosecond and OR gate is also taking 10 nanosecond. So the correct one is option B. I hope now you have understand. Yeah, Nazia, this one is correct. Option B is the correct answer because each gate has a propagation 10 nanosecond. So we have to take both the gates into the account while solving the problem. If we take D, then that one is a correct. That one is not a correct one because they are taking 10 nanosecond for whole process. Okay, so we have to go right step by step or gate wise. First we have to do for this gate and then we have to take this gate also because both gate has a propagation delay of 10 nanosecond. Okay, moving to the next question. So next question is identify the Boolean expression that results from the following VHDL code. So D is equal to A or B, Y is equal to D, NAND C. Okay, so identify the Boolean expression that results from the following VHDL code. So which expression it will give? Option A is equal to A plus B into C dash. A plus option B is A plus B into C. Option C is A plus B and C. Option D is A and B plus C. So please try to answer in the chat box. Okay, I have this doubt in some questions of assignment. Okay, we will discuss. Just let me complete these questions. Okay, Najia, we can discuss it. Let me complete this one. Try to answer this question. Identify the Boolean expression for the results. Related to which assignment question? To this one or any other assignment problems? Okay, previous assignment 10. That this one. Okay. Okay, so try to answer this question. Which option can be a correct? Identify the correct Boolean expression from the given VHDL code. Yeah, option A. So let's say Y is equal to, it is given D NAND C, right? That means D and C dash, right? And D is given as A or B, that means A plus B, or representing the plus sign, right? Now D is equal to A plus B, so we will put it here. So A plus B into C dash, right? Or we can write it is A plus B into C whole dash, right? So yeah, option A is the correct one answer for this question. So for all the following VHDL code, this is the logic expression. So option A is the correct one. Okay. Okay. So the questions are completed for this week. So now you can ask your doubts if you have any. Yeah, Nadia, now you can ask your questions because we have completed the questions for this week. Which question you have doubt?
Ma'am, in one of the questions in which we were having modules of VHDL code.
Yeah, question number you have remember?
No, I can't. No, I don't remember.
So okay,
Not in this assignment which has been posted.
okay. Which one then? Actually, in my slides, that question have or not.
No, it's not discussed yet.
Uh,
Let me check.
okay,
India
that
may-
posted for the current assignment questions related to current assignment questions that have been posted in that portal.
Let me check my. Just give me a minute.
Yeah. Okay, okay, you can check, and then in that case, you have to share that question because I don't have that question. Otherwise, I have to open that.
Oh, I'll just check.
Yeah. Okay. So yeah, Nadia is checking for till now. Any other person have any doubt? They can ask their questions. Anyone else have any doubt?
It's question number 2 of assignment 10.
Two of assignment question. Can you share that one? Maybe
Uh,
because I need to check that.
in chat. Okay, let me see.
Otherwise, you can just post that question
Uh,
in the message
I
box
will.
so that I can see. Otherwise, you can share your.
How do I share? May I share the screen? I've opened the assignment.
Okay.
Can you see the screen?
Can you zoom it little bit? Actually, it is visible, but it is very. Let me
Okay.
wait just a minute. Otherwise, yeah.
Actually, I am also using phone for this meet.
That's why I'm not able to see it clearly. So, what is it? Can you just read it?
Okay.
Question number two. Question number two. It is
Yes, yes, yes.
question number two. Okay, I'm not able to see properly.
Uh,
It is
okay,
possible
ma'am,
to
I'll
zoom it.
share via email.
Okay, just give me some more time so that I can see whether I can set it.
How to share? I share it in the chat box.
Yeah, yeah. If it is possible to share in the chat box, so it's better. I think.
I'm not able to
Just
find the option to share in chat box.
mm, just you can take, I think, a screenshot or and
Okay.
possible just
Mm, I've taken.
okay, I'm also not able to access that.
Mm,
I'm also trying to check so far.
I can't find the option to share in chat box. Google Meet.
Let me check. Let me check. Just checking.
Leave it, ma'am. It's okay, no problem. I'll see.
You
Based
will.
on the, yeah, I'm able to zoom it, ma'am. Which of the following is the correct VHDL entity declaration for the block diagram given? A, B are the inputs to the block and P, Q, R are the output. Entity UT is port A in bit, B in bit, P in bit, Q in bit, R in bit, and DUT.
So DUT is the function. Okay.
Yes, ma'am.
It is not the ports. A and B are the in bit. That means input ports. And P, Q,
Right,
R are the output ports. Right.
right, right.
So which options can be correct? A and B. So I think option C is the correct one, most
Okay,
probably. A
entity.
and B in
Oh,
P. A
oh,
and B are the inbit.
input.
P, Q, and R are the outbit. But in that case, they have end port is not given, right? Entity port.
No, and is not given.
Yeah. So I think it is.
No,
Uh,
I think this is a screenshot I might have missed. Maybe.
okay.
Okay,
So
I'll check.
option C. Option
I'll
C is
check.
the correct one, I think. Because
Okay,
A
I
and
might get access. Yes, ma'am.
option C is the one correct one because A and B are the input ports. That means in bit, and P, Q, and R are the output
Okay.
ports. So A and B are the in bits. P, Q, and R is the output.
Okay.
Most probably, yeah, that one is correct. Okay,
Okay, ma'am. Thank you so much.
okay, yeah. You can stop sharing.
Sure, ma'am.
So yeah, anyone can explain us on the ninth third question problem? Yeah, the- Hema, yeah, you can which assignment in my assignment question or it is related to the current assignment questions. Ninth third question problem. Yeah, it is related to my assignment question problem or yeah, Hema, you can answer. I mean, can you explain it, assignment 9 third question related to which you can share your question also here so that I don't have, I remember the assignment 9 third question related to my assignment problems or the current assignment problems. You're sharing from the phone, so it's not clearly visible. Okay, I will try to. Can you read it? What your address? I think I have also explained the
Hello,
same type of question.
ma'am. Actually, I haven't attended the last class.
Oh, okay. If you have noted, you can see in the YouTube videos are there. So, okay, I will.
Ma'am, you have explained this, ma'am.
Yeah, what you are saying?
You have already explained this question in the previous week,
Not,
ma'am.
I think not the same question, but maybe similar type of question we can. we have discussed. So that what is the input? Okay, from where how we you can find the address range for this. So it is A0 to A7 and 10 to 15 are not used.
Okay, ma'am. I will see. If it is not there, I will next week.
You can ask me either in the next class. Actually, I'm not able to see properly what are the variables. And okay, so let me see.
Okay, ma'am. Okay, ma'am.
Otherwise, you can share your, I mean, detailed screenshot because it is not clearly visible. So that I can do. A0 to, you need to find the address range. Right? Yeah. Yeah, now it is little bit visible that what is the question. Maybe address range is not represented by chip 1. So chip 1 is this one. And the figure is related to that what they are asking.
What is the memory address range is not represented in by chip 1 and chip 2.
Chip.
What is the memory address range not represented by chip 1 and chip 2?
Okay. So yeah, you can. mm, So yeah, let me check. Its memory address is not represented by chip 1 and chip 2. So here A10 to A15. Just write down the all memory range. So 15. A0 to A15 is not okay. That means A0 to A15 is not used. Next, from 9 onwards, 9, 8. You can you can open your so that we can okay. A0.
Hello, ma'am.
Yes, yes.
Are you sharing the screen?
Yeah, yeah. I'm just checking which option can be a correct one.
Okay, ma'am.
A10 to A15 is not used. So that can be a 0 or all 1, 1. So just try to find out which range it is reading or writing. So in that case, you'll able to find
Okay,
out
ma'am.
which range is it is able to not use. Okay, because they are asking which of the memory address range is not represented by chip 1 or chip 2. Okay, so but okay, 0, 6, 0, 2, 0, not that 6, 0, 0.
Okay, ma'am. I'll see if there is any problem. I will ask.
Yeah, yeah. So I think range that can be
Thank
represented by chip 1, chip 2 that is 0, 6, 0, 0 to 0, 6 FF and all other range cannot be because A10 to A15 is not used. So in that case, which range will be not used for this? Just you have to check it. Just find out the what address and range is represented by the memory. Then we need to check which range it is not able to represent by chip 1 and chip 2.
Okay, ma'am.
I think take it in. Okay. Otherwise, you can share the
Okay, ma'am.
question in the email. Yeah. Okay. Can we have a, I think you can post your questions on the portals where you are asking the questions. So from there we can access also. Nazia.
Okay, ma'am. Okay, ma'am. We will be getting assignments editing
Otherwise,
PDF.
otherwise I think you can get an email ID from there. Okay, anyone else have any doubt? Then you can ask. Otherwise, we can close the session. Anyone else?
Thank you.
Yeah, okay. So thank you everyone. Thank you for joining this session. I hope the session will be fruitful to all of you. We will meet to the next class. Okay. So yeah, thank you everyone. Now if you don't have any doubt, you can leave the session. So yeah, you have any doubt? Otherwise we can close the session. Ashok Kumar Das and Suresh. If you have any doubt, you can ask. Otherwise we can close the session. Okay, Suresh, you have any doubt? Okay, I hope all of you don't have any doubts. Okay. Thank you everyone. Thank you for joining this session.